Hello, everyone. My name is Forrest Reinhardt. I teach at Harvard Business School, a number of different classes on energy and agriculture and environment. And it's my honor also to be the faculty co-chairperson for the Andes and Southern Cone region and the Chilean regional office within the David Rockefeller Center for Latin American Studies. The David Rockefeller Center was established about 25 years ago with two purposes: to increase the prominence of Harvard in Latin America and to increase the prominence of Latin America at Harvard. And so to that end, we sponsor and operate a number of different joint projects in the sciences, in the social sciences and the humanities, involving academics from Harvard and from universities throughout the region. And I'm here today, to introduce to you one of those projects, a really amazing undertaking involving a giant telescope in the Atacama Desert of Chile. Now, the Atacama Desert, as you may know, is one of the driest places on Earth, so it's one of the best places to put a telescope. The air is extremely pure. Nothing gets in the way of the vision. And also, as you might not know, we are lucky in Chile to have a community of very dedicated alumni who are committed to helping us do work there. So the extraordinary scientists whom you'll meet in a moment will use this telescope to answer some of the most fundamental questions that we have as people on this planet. What were our origins? Where do we come from? Where are we going? What's our destiny? And perhaps most intriguingly, are we alone, we inhabitants of this planet, on this cosmic journey that we're undertaking? So welcome to Chile, welcome to the Atacama, welcome to Las Campanas. It will be an extraordinary experience.
One makes maybe one discovery in one's life. Discovery is something that changes the perspective, makes it very different what you knew the night before from what you do now, from what you know now. So, if someone comes and tells me we have detected forms of life, that is biological activity, not we haven't seen little green men or something, biological activities in the atmosphere of other planets, that is a showstopper. That is a discovery. It's like when Galileo saw something going around something else that wasn't us. That changed the paradigm completely.
It's part of our job to be very skeptic. But once the discovery stands all the tests and all the challenges we throw at them, it's this sense of awe at something that finally is established, and it's a new realm or a new kind of object or a new theory to interpret what we're seeing. So it's a great and very rewarding process.
The Giant Magellan Telescope is the next big step forward in developing tools to address some of the forefront questions in the physical sciences. And I think it's exciting that there have been tremendous developments in astronomy, from the prevalence of planets around stars other than our own, learning surprising things about the nature of the universe that we inhabit and its future fate. And astronomy is in many ways a discovery-driven science, and advancing the next set of tools to empower people to really look hard on behalf of all of mankind at these really critical questions. I think the GMT is a central element in that enterprise.
So I think that the most amazing thing about astronomy and the astronomical enterprise in general has to do with the idea that we can actually study our origins in the broadest terms. The origin of the galaxy, the origin of the sun, the origin of the earth, how are planets formed, how are galaxies formed, how does matter in the universe comes together to produce what we call, a home, what we call a planet around a star in a galaxy that's, filled with chemical elements that are produced in the interiors of stars that eventually give rise to life. So the astronomical discoveries and the pursuit of the astronomical enterprise, it's really about understanding our own origins, all the little steps and bottlenecks that we had to go throughout 13.7 billion years of cosmic history. So we end up here right now talking to each other. And I think that idea is fascinating. The fact that we can study and understand, these processes and put together a picture of our own origin throughout the whole history of the universe. And the GMT is going to be a key player in advancing our understanding of these origins of the different things that had to happen so we could end up being here.
The GMT is going to be one of the 3 really big telescopes on this Earth. And these are the mega telescopes of the 21st century.
One of the most exciting things that the GMT will be able to do has to do with the fact that it has a superb spatial resolution. It's going to have a spatial resolution that is 10 times better than the spatial resolution that we currently can achieve with, for example, the Hubble Space Telescope. And that will allow us to map the inner workings of galaxies out to enormous distances, way beyond what we can do today, and really understand the internal physical processes that are driving galaxy evolution throughout, long periods over cosmic time.
What we want to reach in the end is we want to try to find terrestrial planets and study their atmospheres. And GMT, the upcoming big eyes, will allow us to cut all these edges of the current technological limitation and hopefully bring us closer to this answer. But other than that, GMT is going to offer a wide range of science kits that the scientists and researchers at the CFA would be interested in, for example, to study the star, how they were born or how they die, or you can also study the galaxies, about their evolution, how they grow, and especially another important question in astrophysics is the origin of the universe.
I'm personally involved in the technology development most significantly right now, but I am super excited about what that technology is going to enable, particularly in the area of exoplanet discoveries, what we're going to learn about as we are able to probe smaller planets and closer in planets to stars than we currently are able to.
The idea that we might be able to collaborate with Chilean astronomers and people at Harvard working and having access to different suites of instruments that are available in Chile and expertise that is available in Chile and at Harvard is really important for getting the most out of GMT in the future.
The GMT is broadly important to all the different areas of astrophysics that we do here at CFA. Partly is what I think of as standalone things that you do purely with the GMT and also synergistically with the other sort of science we do here. We're heavily involved in the Atacama ALMA facility, which does a lot of cosmology, star formation. But my particular enthusiasm is for the study of exoplanets. And we put a lot of effort, a number of my colleagues, prominently Mercedes Lopez Morales, and other people here at CFA, not saying so myself, have worked very hard to sort of quantify whether it's possible or not to do a biomarker search, a molecular oxygen search exoplanet atmospheres for exoplanets that are fairly close, orbiting stars that are fairly close to the Earth. And it seems that we've really got a fighting chance of making that discovery.
Harvard, University of Harvard, and the Smithsonian Institution are both founding members of this telescope, and will have a sizable participation. And having access to a telescope like this opens a completely new world, not only for CFA astronomers, but for all the potential users of these telescopes.
Harvard is playing a key role at developing these instruments. Is playing a key role at developing the project overall and the scientific cases for that will be pursued with the Giant Magellan Telescope. And currently at Las Campanas Observatory, Harvard is already a partner in our existing facilities. The Magellan telescopes, the smaller, the twin brothers of the GMT that came a few decades before them, before the GMT. And so we receive Harvard astronomers at Las Campanas Observatory in Chile all the time to conduct the research. So it's, as I say, Harvard is a key player in this project.
And for Chile, I mean, this is also fantastic and a fantastic opportunity to create collaborations. I mean, we have access to the telescope at Chilean universities. So I'm definitely interested in that. And I have collaborators at CFA, so I'm happy that I think we'll be able to generate new collaborations. Also for students, I think, if I'm correct, I think you, as part of your program, you have, for example, internships that you can send students from there to come here. So that will create a lot of new collaborations to study different areas. In particular, for me, planet formation. I think that's going to be something completely new that we don't have the ability to study right now, and it's gonna open a lot of doors and discoveries that we cannot even imagine right now, I think. So yeah, it's gonna be great.
The CFA was a very special place. Again, as I was doing my grad school search to do my PhD, it was one of these special places in which we had astronomers in the lab experimenting, actively thinking about specifically not just how to characterize these planets, but how to characterize one of the most important biomarkers or signatures of life in the atmospheres of these planets. And that is, of course, drum roll, oxygen. So oxygen is this very special molecule. It makes it is incredibly difficult to detect. We can only do it from the ground, so we cannot do it with, for example, a next generation space-based telescope such as JWST. But we have this special opportunity at the Harvard Smithsonian Center for Astrophysics to actually build the GMT, then build an instrument that is going to be called FIOS, and actually with that instrument FIOS go about detecting oxygen. So that is one of the very special ways in which the CFA is interacting with GMT, is actually not just in the construction of the observatory itself, but developing technology so that we can use this giant light bucket to focus a bunch of light into this very special next generation instrument to go about detecting this molecule that is going to, again, get us closer to answering that question of whether those Earth-like planets in our vicinity, any of them, have oxygen and therefore may have biogenesis occurring in their surfaces and therefore may be amenable to life as we know it on Earth. I think about women in astronomy at the CFA, such as Cecilia Payne-Gaposchkin, who, if you read their biographies, if you read their autobiographies, you can see how they carried their identities very intentionally with them every day of their lives as they did astronomy. And the way I see that with Cecilia Payne-Gaposchkin, who, by the way, is the woman and the scientist that we owe the understanding that the composition of the universe is dominated by hydrogen and helium. The way I see her doing that is I see her carrying her her feminine identity and persevering through all of the barriers that were imposed on her at the time, as she tried really to do her science and make people see her perspective on the composition of the universe. But I also see her in how painstakingly detailed she was about analyzing all of these information of stars that, by the way, other women had collected at the CFA in order to answer this question, in order to basically catalog as many stars in the universe as possible, and then put all that information together to start learning about the universe. And so when I think about the ways in which I bring my Latin American womanhood identity into the table every single day of my life, I think about Cecilia Payne. And that is why it's so special to, I guess in my second year of grad school is when I started being able to come into the CFA every day, come into the lobby of the CFA and see this gigantic portrait of her in the lobby and be reminded that, number one, my womanhood, my Latin American identity have a place at the CFA. And number two, one of the most important astronomers of all time was also a woman who carried that identity with her presently in every single thing she did as an astronomer and also, of course, as a human being.
Chile is like one of the places that everyone talks about.
We expect to have first light toward the end of this decade. And when that happens in Chile, assuming that the European is also being commissioned, that implies that the 70% of the total astronomical capability of the world will be in Chile, which is quite staggering.
The Atacama Desert in the north of Chile is probably the best place on Earth to do astronomical observations. The reason is that, the Atacama Desert has this extremely unique combination of geographical and atmospheric conditions, where you have high mountains, you have the Andes mountain range and the cold, Humboldt current on the Pacific Ocean, which basically means that you have a place where there's almost no humidity in the air. Then in sites like Las Campanas Observatory, we have, of the order of 300 clear nights a year, which is really, it increases the amount of time that you can use this facility. And also the quality of the images that you can get because of how stable the atmosphere is at Las Campanas Observatory is extremely, good. It's one of the best observatories in the world in terms of image quality. So when you have a telescope like the GMT, the capabilities of the telescopes are one thing, but where you put this telescope, really can make an enormous difference in terms of how deep you can go, how faint objects you can detect, and the quality of the data that you're gonna get with this facility.
It is also very important to observe continuously. So you want to know how the system changed through time, and sometimes you have to come back and repeat the observation in, say, a few days or a few months or a few years. And in that particular time, you would need like the perfect condition of the sky. And Chile will give that perfect opportunity for you.
For Chile, it's fantastic to be able to have access to this fantastic instrument, especially since given the atmospherical conditions and the observing conditions in the north of Chile, we can combine this instrument with other amazing instruments for looking into the universe, like the Viruin Observatory, meaning we will have GMT to follow things that change in the sky right away. We'll have the best transient finder tool right next to GMT. We can combine it with ALMA observations, the best radio telescope in the world. And GMT is also right next to other great facilities that will make its science output so much better.
I believe that it could become one of the important center point of contact where Harvard and Latin America can connect, especially between the researchers and local community. And in my opinion, outreach is also important to gain the support from the local community to understand and get them interested in what we do, in particular in Chilean community, which has a fast growing astronomical research, scientists and engineers. So we should also encourage more of this kind of collaboration between Harvard and Chilean Astronomical Society.
With the GMT, we really have a very special opportunity to reflect on the people who are sitting at the table asking these questions that have accompanied humanity for so long, such as the question of whether there is life or not elsewhere in the universe. So we can really go back to thinking about who's sitting at that table and specifically make sure that, because it's a question that belongs to all of humanity is represented in the group of astronomers going after answering these questions. And I think that having an observatory such as powerful as the GMT in a Latin American country as beautiful and culturally rich as Chile is going to actually facilitate that self-reflection and make it more likely that we have a diverse community going after answering this absolutely fantastic and mesmerizing question.
We have a solid network of infrastructure in terms of communications, fiber optics, roads, accessibility to the sites, etc., which is really great, and it's important in terms of handling these operations in these very remote locations, and also the country. It's a place that has a level of political stability and development that allows for a very efficient operation of a high-tech, large scientific facility. So that's why the site that was chosen for the GMT, it really provides an enormous advantage to the project, and this is something that Chile and the Chilean government and the Chilean people really, have in their minds as something that it's important for the country. Astronomy has become an essential part of the image of the country, and the protection of these sites is becoming more and more relevant, especially in terms of protecting these sites against light pollution. So, for example, the Chilean government has imposed a series of regulations to the illumination of cities and industries in areas that are near astronomical facilities, in order to make sure that we can take advantage of this beautiful natural laboratory, this window to the universe that we have in the Atacama Desert for decades to come.
Well, the GMT is really, we expect it's going to be a breakthrough. Astronomy historically has advanced through breakthroughs enabled by larger telescopes or new technologies, say more sensitive detectors. So as the GMT arrives with a greatly increased size in comparison with existing telescopes, it opens new windows into the universe. And as such, it will allow for us to peer deeper, faster into the universe. And if history is any guide to what will happen, that will lead to many breakthroughs.
We're also going to be able to push the envelope enormously in terms of observing the most distant objects in the universe, the first galaxies that are born, and we're going to be able to observe them as they evolve in the very early epochs of the universe, in the first, let's say, 5% of the history of the universe. Also, the GMT is going to be able to characterize planets, extrasolar planets, about other stars in the Milky Way with exquisite precision, a precision that should be, high enough that would allow us to detect the presence of Earth-sized planets orbiting around solar-type stars, which is a part of the parameter space in the search of extrasolar planets that today it's beyond the reach of any existing instrumentation?
Well, it'll be the next big leap forward in technology for people doing optical and infrared astronomy. So it should open up new areas of research. We already have ideas about what questions we'd like to answer, search for planets around stars, search for life on those planets, chemical signatures of life, including oxygen on those in the atmospheres of those planets. And so there's a lot of exciting plans being formulated, but even more exciting will be the questions we haven't even thought about asking yet, and that will come upon it in the years ahead as we have these new tools available to us.
We know it's going to happen, but perhaps the most exciting, it's that it opens new realms. And if you look back, very often the most striking discoveries of these new facilities were not foreseen.
I'm just excited to see what it's going to discover. I mean, there are lines of research that, they developed the telescope to study planet formation in particular, but when you have a new telescope, you never know what you're going to find.
Are we alone in the universe? Are we going to be able to find something similar to Earth? And if we find the Earth-like planet, whether they are habitable or not.
Being able to observe extremely faint objects opens new worlds. So I think there is a very bright future for astronomy in the first 2 decades or 3 decades of this century. And I encourage people to follow their nose, and if you have an idea, pursue it, work hard, and think of the enjoyment it's going to be when you make either a discovery or a pretty interesting finding.
GMT is really a brand new window into a place where nobody has really looked before, by having one of the largest collecting areas in history and being placed in probably the best place in the world for astronomy from the ground. It will allow us to study how the very first stars formed in the earliest galaxies, all the way through our nearby neighborhood, where we can basically take a look at the nearby stars and the nearest planets and see and look for evidence of life. And maybe, if we're not that lucky, to compare how nearby planets look with respect to how things look in our very close neighborhood. And again, put our own solar system formation history in context. So it will really be a game changer. And anyone that has access to data coming from GMT will be lucky to be able to look at things with brand new eyeglasses for the first time.
The GMT itself will be an enduring flagship for astronomy, astrophysics, physical sciences, and science in general. And we will use it in ways that we can't possibly imagine today. I think that, getting to the threshold of turning the GMT on, learning how to use it, exploring the possibilities, the scientific data that comes out of the GMT will pose new questions we don't dream of today.
I think it's sobering in the multiple challenges that we face across the globe right now, between pandemics, economic challenges, social strife, to think hard about what our priorities are as a civilization. And I'd like to think that astronomers act as ambassadors for all of mankind so that we can learn more about our place in the universe, learn more about coming with a humble perspective to the earth that we inhabit. And I hope very much that we can find the opportunity, the passion, and the commitment to carry through with the investments on resources like the GMT to allow that important work to continue.
Good afternoon, everyone around the globe. I'm here in Santiago, Chile, supporting the 24 Hours at Harvard initiative. My name is Marcela Renteria, and I am the Executive Director of the Chile Regional Office of the David Rockefeller Center for Latin American Studies at Harvard University. You just saw this incredible video with remarkable voices of faculty, protagonists, students, and researchers from the Smithsonian Center for Astrophysics and other departments at Harvard, and from astronomers in Chile. They are all explaining why this supergiant Earth-based telescope promises to revolutionize our view and understanding of the universe. Chile was selected as the best site for the Giant Magellan Telescope because of the country's outstanding astronomical position and clear weather throughout most of the year. The Harvard office in Chile and the Andean Southern Cone program at Dr. Class support this project for the benefit of humanity with scientific advances that will help us to expand our horizons. We're not only proud of it, we want to be part of it. I want to thank my colleagues, Jimena Codina and Mike Oliveri, for making this happen. Are we alone in the universe? The Giant Magellan Telescope in Las Campanas, Chile. I am here with a group of Chilean astronomers, and I would like to introduce my friend and colleague, Cesar Fuentes. The idea is that we're gonna have a live conversation, and Cesar will present some of these ideas with our colleagues. Cesar is an astronomer from Universidad, Chile. He's a PhD in astronomy from Harvard in 2010, and he's a great collaborator of this idea. So Cesar, I'm gonna leave the word to you so we can share with the world why we're here and why this is important to us. Thank you all for being here.
Thank you, Marcela. Pleasure to be here. With me, we have Teresa Paneque. She's a recently minted master's student from Universidad Chile, and she's going to continue her PhD at the ESO at Garching in Germany. We have Miguel Ross, the former director of Las Campanas Observatory and currently the representative for the GMT in Chile, as well as Andrés Jordán. He is professor at Universidad Adolfo Ibáñez and the director of the Millennium Institute for Astrophysics. And I met him at CFA actually as a Clay Fellow. So it's a pleasure again to have all of you to discuss this wonderful new opportunity that the GMT offers for the world and for me and you and all of us. So I'm pretty excited to be discussing this in this context. So to tell a bit of the world how we Chileans feel about this new instrument, this truth machine that will bring evidence to some really big questions that at least I'm interested about. What are you guys most excited about with GMT? What are you most excited about, Miguel?
I would say most of us who would like to see the GMT finished soon and being used goes from the closest to the furthest. We are very excited about, obviously, detecting life in the universe. Are we alone? A few days ago, it was suggested that in Venus there might be life, but it's unlikely that we would like to contact life there. They probably don't smell too good. But is there life in other planets around other stars? That's the fascinating question. No? And we're not going to take pictures of little green men or so. We're going to try to detect biological activity in the atmosphere. So that's the most exciting thing for me. If I'm still alive, I'm going to be very happy to hear about that. And if not, as I said once, go wake me, tell me that life has been discovered somewhere else, and I'll continue sleeping peacefully. And I let other people talk about the furthest parts of the universe, no?
What are you most interested in, Teresa? Is the prospects?
Well, yeah, well, I study planet formation. So I like to study the protoplanetary disks, the places where planets form. And I think that something that's very interesting is how we will be able to combine the measurements taken by the GMT at high resolution using its adaptive optics system to analyze, for example, the small grains in the upper surface of these huge disks of dust and gas, where we are hoping to find any dynamical signature of planets forming with telescopes such as ALMA, for example. And we will be able to measure with the GMT the small grains tracing the upper surfaces of these disks, and also try to directly image the thermal emission from planets that have just formed. So the high resolution that GMT will be able to offer will be compatible with high resolution we have from radio observations of ALMA, and then we will be able to see the whole picture, because in astronomy it's very important to try and trace different phenomena at different wavelengths, and then we can understand better all the processes that are ongoing. So for example, with ALMA, we're seeing gaps, we're seeing spirals, we're seeing vortices appearing in these planet formation sites, which are protoplanetary disks. And it is amazing when we can detect also a signature of maybe a planet, as can be observed by the GMT, possibly within one of these gaps that ALMA is showing. Also, something that I find very interesting is the resolution. So we will have a 5 AU resolution at 150 parsecs, which is where the planet formation sites currently reside, more or less. And this is interesting because currently we have seen direct images of planets forming, but very far out. So in our own solar system, what we are interested in looking at is in these planet formation sites, what is going on really close to the star. So hopefully someday at 1 AU where Earth is. But seeing things at 5 AU resolution will also allow us to see possibly planets that may be comparable to what we have in our solar system. So I think it's really exciting stuff what we will be able to see with the GMT. I think that combining these observations with other wavelengths will also help us gain more knowledge, and well, a lot of things will also be going on with planets that are already formed, but I guess maybe Andres will have more to say on that respect of planets that we know are already there. I'm very excited about planets that are forming.
What about you, Andres? You've been called out.
Well, I'm excited about a bunch of stuff. I think, we've been discussing for a long time, when you plan for such a big new machine, you try to write down to justify the expense, what are the things you expect to find. And, among those things, I think I'm also very excited about the possibility of finding molecular traces that may betray life in nearby planets. But to be honest, what I'm most excited about is what I don't know. With a new machine like this one, you open a new window into the universe. And if history is any guide, very often the most spectacular results were not anticipated. So I'm just excited for the thing to be installed, have first light, have this wonderful new suite of instruments, some of which are being built at the Center for Astrophysics at Harvard, and just open the window and see what's out there. And that's, yeah, I'm most excited about what I don't know, what that new window will let us look into.
I, for one, am excited for having this incredible machine right next to where other big investments in astronomy are located. So having GMT very close to where LSST or the Bilirubin Observatory is located will mean that we'll have the best eyesight right next to where things that change in the sky are discovered.
There's also something very exciting that doesn't have to do with the direct science, but having such a wonderful machine close to us. I'm based in Santiago, and it's a short trip to get up there. But these machines, these big telescopes, are just amazing, and it's you feel like when you're next to them, and you see them, you're in awe, and just being able to go there and take a look at it and just use it. It's just wonderful, and and like having a toy close to home, you know, a super nice toy.
I think it shows also how the big, let's say, revelations or discoveries in science and astronomy are just so closely linked and dependent on the technology development that we have. So I think this is also why these next few years are going to be so exciting. So as Cesar said, we have the Vera Rubin coming on, we have the GWST, if everything goes well, the GMT. So there will be a lot of new instruments that will really just, I think they will revolutionize what we know of science so far. And I feel very fortunate that I'm just starting my PhD also in an observatory. So I think that as astronomers, we have to be very closely linked to the new technological developments that are going on in the field. This is something amazing for Chilean scientists, because as Andres said, we can easily go to the sites from a student level, even as undergraduates. We have the opportunity to go and observe. We have the opportunity to interact with the telescope operators, with the people that are making the observations, with the engineers. And this is crucial because if you understand the instrument that is doing the science, that is observing, then you can better adequate your observing proposals. You can understand better the science goals of something in line with what is available. So I think that it's a great thing for Chilean students. It's a great opportunity for collaboration. And it also shows how multidisciplinary astronomy is, not only within the science. So obviously within astronomy, you collaborate with people from different teams, with people that study different phenomena, but also you collaborate with people of different careers, of different professions, like engineers, like technicians, people that are in informatics and computing and software development. So it's really amazing, and I think that we're living very exciting times.
I was born too early, that's clear. And you realize also how many people with how many different skills are work behind the scenes, let's say. You have engineers, you have high-level technicians. It's not just astronomers working at the telescope. It's all that keeps the telescope working, that keeps an observatory running. It's staggering.
Completely. I think it's important also to acknowledge the presence of all these people. I think it's very important, especially when you're promoting science and astronomy to the younger generations, to say there are many paths, many career paths to be involved in astronomy, to be involved in studying the universe, not only the academic, not only doing graduate school and scientific, let's say, like papers and publications. You can also help from being hands-on in building these amazing instruments that are the core towards being able to study the universe. Because if we don't have this resolution, if we don't have these instruments, we're just blocked. I mean, we're blocked from being able to see further in. And this is why the GMT is so exciting, because it will allow us, it will open a new window and see further in. It's like having a camera with 5 pixels versus having an HD image. So I mean, I think it's just that you need these instruments.
It's kind of humbling to think that, you know, we may be able to address directly some of these big questions like life in the universe in our lifetimes. It's and with something that's sort of just around the corner. Of course, you know, we've been learning a lot. You know, already our view of this question has changed so much in the last 20 years. Only since 1995 do we have certainty that there are planets around sun and stars. And from that time until now, we know that there's just literally millions of planets out there, and many of them may share some important characteristics with Earth. And so, you know, you keep pushing, Okay, so we know they're planets. We know some of them are like Earth. You know, okay, so do some of them show signs in their atmospheres of possible life activity? And you know, we will be able to address that question with the GMT for nearby planets. So, you know, will we find something? We don't know, but we may, and that is super exciting. And you know, it's poetic, as you point. You know, there's poetry in the question, and there's poetry in the undertaking. But going back to our previous discussion about technology, that poetry is so deeply tied to the technology and the whole big enterprise of making this machine work. So it's very lofty and poetic on one side, but very down to earth on the other. And for me, that was a big draw of astronomy. You connect something that's very far away, kind of out of reach, fundamentally out of reach, too far away, with something that's very concrete. A detector with so pixels and electronics, and you gotta go and make that amplifier work for your photons to be converted into your electrons, and you have to have this whole team of engineers. So the wide variety of expertise needed to address these questions, I find it fascinating too, and it connects not only to machines and technology, but to people. It's something I didn't mention, but also something for me very important of the GMT is its location. I've grown to really love Las Campanas as a place and as a community, and of course Miguel, can tell us much more about that. And yeah, just the machine comes with the possibility of still being connected to this community, which is a very special community.
And the food.
I remember being a TA for one of the entry levels at Harvard, and one of the things that was always mentioned by astronomy professors when they were talking, 1987A, this supernovae that was discovered at Las Campanas, was how good the food was. And what was the secret of the pizza? I was asked. So we really expect that things will not change in that respect at that site.
That I can't guarantee. But
I have to say, there's also poetry in this collective effort of people getting together and collaborating into something bigger, different, something that maybe you won't see the results from, and that you hammer on for other people to take over and actually advance as a group. So yeah, I completely agree. Yeah.
Do we all think there is life out there, or?
In Venus, come on, the atmosphere. No, but I think the chances of life being in the universe are very high. We have to be very egocentric to believe that we're the only planet with life. Now, the question if it's intelligent life, I'm absolutely certain that microorganisms exist by the thousands in other planets. And we also have to keep in mind that we're only studying and detecting planets within our galaxy, but the universe is extremely large, and we have thousands of galaxies, millions of galaxies, similar and different to our own Milky Way. So I think that it's impossible from a statistical point of view that there's no other planet with life similar to Earth. And then we have to also think about the possibility of life being based on different chemistry, on a different context as an Earth. So I always say yes. Now, if I think intelligent life, aliens are coming to Earth, I would say no. Also because of probabilistics, and look at us. We have these amazing telescopes, and I'm sure we would not be able to detect a planet such as Earth around a star like our sun. So, if these aliens detect Earth, they have even better telescopes. So you could also address the question from an engineering point of view, like what resolution, what size would you need to be able to detect a planet such as Earth from another planetary system within our galaxy, for example. And it's going to be hard because the technology barrier to detect planets such low mass around medium stars is difficult. So I think life exists. I do not think that intelligent life is coming to visit us on Earth. But I do think that we have thousands and plenty of microorganisms, maybe and possibly even in our own solar system.
Yeah, I agree. I think in terms of microorganisms, I think the most likely place we'll find it first is probably our own solar system. There's a number of very promising places. Venus is not particularly welcoming, but there are other more welcoming places. But are we alone in the universe? I think even though the universe is probably teeming with life. In a deep sense, we are alone because, you know, everything is far away. It's so far away that, you know, communication doesn't become a likely possibility, as Teresa said. You know, it's they're not going to come visit us. We're not going to go and have tea with our with the civilization in the next door. So, you know,
It's dubious, yes.
very likely that there's life in abundance, but we're kind of alone.
So one of the big things that we were thinking is how the Harvard office here in Chile could be useful or helpful in the future once it is installed, and how we can connect more the smaller students into the telescope, or connect more Harvard students with students from your universities. So I just wanted to hear a little bit about your vision of how we could collaborate in the future more, now that we're establishing that GMT is going to be more and more a reality for all of us.
I think, you know, scientific collaborations is very much like forces in the universe. You need particles to interact with each other, and those particles are named, you know, are people. So students and astronomers and researchers. So having people, you know, interact, go to Harvard, come to Chile, interact with different institutions, and get to know the people, the human experience of sharing the quest of finding an answer for one of these problems is something that changes you and that enables, you know, good things. More, you know, that sprouts like life. I think that's what one would want happen more with something like GMT coming online.
Yes, I think also to add to what Cesar is saying, also this pandemic, this whole year, 2020, has shown us that there are many things that you can do online. So even just doing maybe joint seminars, joint colloquiums, being able to interact virtually with the community at the CFA and the different communities at all the Chilean universities would be a very nice and enriching experience for the students, the faculty as well, to learn how different maybe the ways of teaching, of learning astronomy, of conducting research are. At Universidad de Chile, where I did my master's, specifically with my group led by Dr. Laura Perez, we have had the chance to interact with Sean Andrews' group, for example, at the CFA, and the work that they've been doing on protoplanetary disks. And it has been an amazing experience. I think you can learn a lot by getting to know how other people are doing the same work. So for example, what are the tools that they use, what are the prescriptions or the way that they organize themselves. So it will be, it could be even easier to do this intercultural exchange by using all the tools and the platforms that we have learned to use during this pandemic. So I think that there will definitely be the opportunity and the methods to do a lot of collaboration with the Harvard office, especially once the GMT starts running and in these coming years where everything will be getting ready.
Yeah, I mean, many of us have ongoing projects with researchers at the CFA, and you know, those offer natural opportunities that not always have been exploited to their fullest potential. So it's just a matter of, you know, looking at what we're doing. Of course, the GMT offers a very natural platform for, you know, there's some ongoing collaborations in the context of the GMT. For example, in my case, I'm a co-investigator on one of the instruments that's going to go first, the GMT, and that's being led by Andy St. Georgi at the CFA. You know, that offers a lot of opportunities for undergrads and grad students on both sides getting involved. I have another project that's gearing up to use that same instrument to peer into the atmospheres of planets. And again, it's, you know, the collaborations are, and I'm not the only one, there's many other collaborations between CFA researchers and lots of people in Chile. So the opportunities are there. The GMT will just enhance those collaborations, and we got to go and exploit those projects and in particular to get more undergrads involved. I think that's always the hardest, but it's, whenever I've done it, it's a very rewarding experience and it can be done.
I think that's a big takeaway message is if you're an undergrad, get the opportunity to go observe it and do it. It's a great experience. In many...
Go pester your professors to have them send you down. It's an experience. Dinner tables at observatories are a fantastic place. Fantastic. Not only because of the dinner, obviously, but the kind of conversations you can start, what you learn, what you hear, intercultural exchanges. I'm a fan of it.
So I'm very thankful for this opportunity to have this discussion with all of you. And I'm looking forward for GMT to come online. I don't know if you guys want to say anything, closing remarks.
Thanks for the invite to speak. It was a pleasure.
Real pleasure.
Thanks for inviting us. It's been a real pleasure chatting with you.
Yes,
have a
thank
wonderful
you very
evening.
much.